Assalamualaikum and good evening, afternoon, good night to all my dear friends. Today, I will present my presentation about this data structure problem-based exercise 1. So this question is given is question 1, create a queue, initialize an empty queue. So the answer will be this one, this coding. So in this coding, this coding involves setting up a queue data structure using a linked list. So the queue is defined by two pointers. It is the front and near. So initially both front and rear are set to null pointer since the queue is empty. So we go to the question 2. Question 2 is, if empty, check if the queue is empty. So the second one, bool is empty, return front null pointer. So in this coding, this operation checks whether the queue contains any elements. If the front pointer is null pointer, it indicates that the queue is empty. So this function return boolean. This function will return a boolean value true if the queue is empty, false otherwise. It's a simple check that compare if front is null pointer. So the third question is, in queue, add an element to the end of the queue. So we go to the coding given. Right, this coding explain about the enqueue operation adds a new element to the end of the queue. A new node is created with the given value. If the queue is empty, both front and rear are set to this new node. If not, the rear node's next pointer is updated to the new node, and then rear is updated to the new node. So the details on this coding is, the first, they create a new node with the given data and set its next pointer to null pointer. If the queue is empty, update both front and rear to point to the new node. If not, link the current rear to the new node and move the rear pointer to the new node. So we go to the next. DQ, remove an element from the front of the queue. So the coding is this one. Okay, the detail on this coding is, first, check if the queue is empty. If it is, display an error message. If not, move the front pointer to the next node. And then if the queue becomes empty, the front is null pointer, update rear to null pointer as well. Delete the old front node to free memory. So next is display print all element in the queue. So the coding for that one is this one. Okay, first one, if the queue is empty, print a message indicating that. Otherwise, traverse from front to rear, printing each node's data. Each node data is print until time the current node pointer becomes null pointer.
Hello. Assalamualaikum. My name is Muhammad DANIAL bin Muhammad FAIZ and my matric number is 0123F1086. And right now I'm going to present about the question 2. So firstly, A, create a queue. So this is queue that I have created. This is front and rear because there are no value inside this queue. So for the next question is B, and Q 2024. So we need to enter this value inside this queue. So this one is 2024, and the font will be this one, and red will be this one, because there is only have one value inside this queue. So for the next one is NQ 2020. So we need to enter this value inside the queue that we have created, and 2020 we will put at the back because the queue concept is first come first serve. So 2024 will be the first, which is front, and 2020 will be at the back, which is rear. So the next one, DQ. DQ means we need to remove the first item or the front item from the queue. So the front item is 2024. So if we DQ, we can only see the 2020 in the queue. So for the next one, NQ 1969. So enter this value inside the queue. So 2020 will be in front, and 1969 will be at the back, which is red. So for the final one is DQ. So DQ the first item, the front item, which is 2020, and it will be 1969 in the last queue. So this is the front and rear. So for the next question is question 3. A. Create a linear queue. So question 3 asks us to create a queue but in the linear form. So this is the queue. So for the first question, NQ 10, the value of 10 inside the queue. So I already put it. So this is the front and the rear. So the next one is NQ 20. So as I said earlier, the queue system is first come first serve. So the 10 will be at the front and 20 will be at the back. So the next one, NQ 30. So the first one 10, 20 and 30. So the front is 10 and rear is 30. So the next one, NQ 40. So it will be 10, 20, 30 and 40. The front one will be the same, which is 10, and the rear one will be 40 at the back of the queue. So the next one, NQ another value, which is 50, 10, 20, 30, 40, 50. So the first one will be the front, and the back one will be the rear, which is 50. So the next one is DQ. DQ means we need to remove the first item, which is the front, this number 10. So if we already remove, so the value is 20, 30, 40 and 50. So 20 will be the new front because the 10 value already removed, and the rear one will still be the same, which is 50. So for the H, DQ another item. So we need to remove another item at the front. So 20 will be removed and 30 will be the new front, 40 and 50 will be the rear. So for the next one is we need to NQ 60. So we need to enter the value of 60 inside this linear queue. So the front will be the same, which is 30, 40, 50, and the new rear is 60 because we put the 60 value at the back of the queue. So for the next one is Q another value, which is 70. Front will be the same, 30, 40, 50, 60, and the new rear will be 70. And K, DQ. DQ, we need to remove the front, which is 30. So if we already remove this item, the answer will be 40, the new front, 50, 60 and 70 will be the rear. And the next question is DQ another value, which is 40, And the answer will be 50 front, 60, 70 will be the rear. And lastly, NQ 80. Enter the last item, which is 80. So the front will be 50, 60, 70, and the new rear will be 80. So that's all from me.
Alright, back. So this is the last question for this PBE data structure. Question 4. First is create circular queue. So this we have the empty circular queue, and the front and the rear will be at the same value, same index at -1. Next is NQ10. We have to insert the 10 into the queue, so the front and rear will be the same index at 0. So the queue is now have value 10. Next is 20. Insert 20 into the queue, and the rear will be different. The rear will be at index 1, and the front will be at the same place as before at index 0. Next is NQ30. We have to insert 30 into the queue, and the rear will be at index 2, and the front will be at index 0. Next is NQ40. Insert 40 into the queue, and the rear will be at index 3, and the front will be the same place as before, it's index 0. Next is 50. Insert 50 into the queue, and the rear will be at index 4, and the front will be at index 0. So next is we have to dequeue. So dequeue, we have to remove the element at the front, remove 10, and update the front value. The front value will be at index 1, and the rear will be at index 4. So the new queue is null, 20, 30, 40, 50. Next is we have to dequeue again. Remove the element at the front, so we have to remove 20. So the front will be at index 2, and the rear will be at index 4. The new dequeue is null, 30, 40, 50. Next is we have to insert 60 into the queue. So the rear will be at index 0, and the front will be at index 2. So the queue is 60, null, 30, 40, 50. Next is we have to insert 70 into the queue. So the rear will be at index 1, and the front will be at index 2. The queue is 60, 70, 30, 40, 50. Next we have to dequeue. We have to remove the element at the front. So we have to remove the 30. The front will be different this time. The front will be at index 3, and the rear will be the same place as before at index 1. Next is dequeue again. We have to dequeue, remove the element at the front. So we have to remove 40, and the front will be at index 4, and the rear will be at index 1. So the queue is 60, 70, null, 50. So the next one is we have to insert 80 into the queue. So we have to insert 80 into the queue. So the rear will be at index 2, and the front will be at index 4. So the queue is 60, 70, 80, null, and 50. So that is all question. Thank you.